I am so glad you convinced me that the family car should be the Defender 110. It is so beautiful inside, it's so comfortable, and it just feels indestructible.
Yes, it really is. I've been waiting a long time for the new model to come out. The Defender 110, I'm telling you, it's my favorite car of all times. It's my third one. You know, I have stories of going off road. The guy managed the group. He was like, "What are you doing in this beautiful car?" I'm like, "I'm going off road." He's like, "Are you sure? Because you can use one of ours." And then they look like Mad Max cars. I'm like, no, we're going to do this. And he was shocked.
Wow. Well, it's great because the Defender has been reimagined for 21st century adventure, and its unparalleled off-road ability as well as its robust interior are invaluable whether you're headed towards uncharted territory or just a weekend of exploration. The Defender 110 tackles challenging surroundings with absolute confidence. The SUV conveys strength outside and in, featuring peerless technology like an intuitive driver display and an award-winning infotainment system. That's my favorite part, to keep you connected no matter where the journey takes you. Adventure is unique to everyone, and so is the Defender. Choose from the two-door Defender 90, the four-door Defender 110, or the larger Defender 130 with the ability to seat up to 8 passengers. You'll find uncompromising performance in all three. So pack up and go even further with the Defender 110. Learn more at LandRoverUSA.com/Defender.
These days, we're all investors, trying to be smart with our money despite our worst impulses. But at iShares, we believe that deep down inside of every investor is a better investor. One that's just waiting to be let out. Explore iShares ETFs and insights and let your best investor out. Visit iShares.com for more information.
This isn't your average business podcast, and he's not your average host. This is the James Altucher Show.
So, Matt, you just mentioned you love talking about this topic, which is we're going to talk about COVID and the latest developments in the news about COVID. And of course, you've written the book Viral with Alina Chan from Harvard about your insights then into COVID, and now there's been some new stuff. But I'm curious, why do you love this topic? You've written so many amazing books that I've read through the years. Like, it's such an honor to be talking to you. The Rational Optimist is still perhaps the number one or number two book I recommend to people who want to understand just economics and the history of economics and why it's important to be positive about what's going on, even in the worst of times. Your book, The Evolution of Everything, has inspired my thinking in so many ways. You've written about, everything from genomics to history to economics. What inspired you to write about COVID?
Well, it's a very good point. There are much more grandiose and spectacular subjects in the world. There are wonderful things and extraordinary things going on in science, in technology, in economics, etc. Why focus on this one dreadful virus that has messed up our lives so badly? And the answer is because, when I say I love this topic, in a way, I hate this topic. I hate the fact that we have to try and find out how a devastating disease killed 20 million people. That's an estimate, but it's a credible one, without being able to interrogate the data properly because a secretive regime won't let us. So my obsession with this subject comes from a sort of righteous fury about the failure of the world to tackle this subject properly, rather than gosh, I love this topic and I really want it to be interested in it. In some ways, the position I take, which is that we don't know what happened, but we very strongly need to consider the possibility of a laboratory leak because a lot of the evidence points that way. That position is one that's very uncomfortable for me personally, because it points to biotechnology having made a very harmful mistake, which will set back the cause of biomedicine and biotechnology considerably, and it will give succor to, anti-vax sentiment, anti-science sentiment of all kinds. But I'm sorry, I believe it was Solzhenitsyn who said, although I've not been able to find the quote, "Truth matters more than consequence."
And so, It's interesting because in the beginning of this pandemic, back in 2020, I spoke with an epidemiologist who very much insisted that there wasn't a lab leak, that they had kind of debunked that pretty significant, like with 100% surety. But now, of course, and in your book Viral, you suggest it might have been a lab leak, and now there's more evidence now suggesting that it probably was a lab leak, as opposed to just happened to coincidentally be in the wet market across the street from the lab where they were studying this very virus. So what's been new, and what do we do about it now that we have this new knowledge? And that's really related to the broader questions of why has information become so polarizing about this topic? And
Yeah.
and I guess the final way I'll turn to this is, what does the rational optimist say going forward about this?
Yeah. Well, so let me just start with what's new. And I can't remember when I last spoke to you, but
I will tell you, it was probably about a week or so after your book came out. It was probably around the turn of the year.
right, exactly. Okay. In 2021, the world moved away from the position. By the world, I mean the World Health Organization, the US government, the main scientific organizations, the main media organizations. They all agreed that actually it was an open question, not a case closed. That we couldn't rule out the lab leak as a conspiracy theory because lots of evidence had come forward, and that it needed to be investigated seriously. That was the position we kind of all agreed on. And in particular, a document had dropped in September 2021, which was very startling and very worrying. It was a grant application from within the United States, but in collaboration with the Wuhan Institute of Virology, to put a feature into a SARS-like coronavirus when they found a new one that is exactly the feature that we've since found in this virus and that has never been found in any other SARS-like coronavirus to this day. So it's a recipe for producing this disease, basically, that was being considered in 2018.
This was a patent filed in 2018, or this was a research report filed in 2018?
This was a research grant application to the U.S. Department of Defense in 2018 by a U.S. organization in collaboration with the Wuhan Institute of Virology. Now, as far as we can make out, it was turned down by the U.S. Department of Defense. But we know that quite often when you apply for a grant, you've already started doing the work. We know that the major funding of the Wuhan Institute of Virology did not come from that source. It came from the Chinese Academy of Sciences and so on. So that's a very important document. It came out just before our book came out. What's happened this year is that there's been a very strong pushback from a number of Western virologists who, rejecting the Chinese line that they don't now think it started in that market. George Gao, the head of the Centers for Disease Control, says it was a super spreading event, not a origin event. That's the head of the Chinese Centers for Disease Control. But a number of Western virologists have pushed back against that and said, no, we really, really do think it started in the market. And we're basing this on an analysis of some of the early cases, about 150 cases that they've looked at in December or early January, which seem to be centered on the market. And we know there were traces of the virus in the market, but not in animals, on things like doorknobs, countertops, and in sewage and so on. So that, we think, they say, is dispositive evidence that it started in the market. Now, there's huge problems with that. First, the data is incomplete. We know there were cases in November and December. We know from the South China Morning Post, which got leaked documents, that there were at least 9 cases in November, for example. So we know that the data is incomplete. And we know that the one thing you would need to be absolutely sure that it started in the market was an infected animal, is an infected animal. That's what we had in the case of SARS in 2003, a palm civet with a 99% similar virus that was infecting people, case closed. That has still not turned up. And it's very implausible that the Chinese would hide that at this point, even though they don't terribly want to blame their own market either.
But Matt, I have a question also. Like, even if it's quote unquote the first case started in the market, wouldn't it be Occam's razor that the lab literally across the street from the market might have leaked?
Well, it's not literally across the street. The main lab, there are about 7 or 8 labs working on coronaviruses in Wuhan. the Wuhan Institute of Virology was in the process of moving from one that's about 8 miles from the market to one that's about 13 miles from the market. But there is a Centers for Disease Control lab, which had been collaborating with the Wuhan Institute of Virology, which is right across the street from the market. So and in to pull back the image just a little bit and look on a wider scale, this disease broke out in the one city that had the largest and most intensive program of research and manipulation on bat SARS-like coronaviruses in the world, bar none.
Right. So it's an odd coincidence
nowhere else in
that
the world was doing this. And by the way, they weren't local. They weren't picking up the viruses in the local community. They were getting them from 1,000 miles away in Yunnan and Laos and other countries. So, they were bringing viruses of this kind a long way to Wuhan, studying them, sequencing them, manipulating them, infecting human cells with them, infecting humanized mice with them. This wasn't happening in any other city in the world. It just so happens that this is where it broke out. So, it's I like to quote the Humphrey Bogart line from Casablanca: of all the gin joints in all the towns in all the world, she walks in a mine. Or actually, an even better analogy is 2007. There was a foot and mouth outbreak on a farm in the UK in Surrey. It was just 13 miles from the world's leading foot and mouth virus reference laboratory. That wasn't a coincidence. They immediately investigated. They found that a contractor had mended a pipe at the virus and gone straight to the farm, and that's how it had started. This is just as coincidental, if you like. But I was just going to go on and say what else is new, because there are actually new stuff in the last few weeks, which is quite interesting. And one of them is the Senate Help Committee in the US, which the minority staff of which, on the Republican side, spent a long time working on a report which they produced, which shows very convincingly, in my view, that there was some kind of biosafety crisis in that lab in November of 2019. That there were high-level meetings, there were senior people from Beijing who turned up to discuss improving biosafety in the lab, and the terminology they used and the wording of the documents that were seen very strongly suggests that they were reacting to something that had gone wrong around that time.
How did the Senate know this?
By reading these internal documents that were not secret, but they were party documents, very hard to get hold of, but they managed to get hold of them, in which the internal affairs of the laboratory were discussed in detail. So that's sort of the picture where it comes from. Now, that in itself doesn't prove anything, but it is suggestive. The other thing that came out in the last few weeks is that a team of 3 molecular biologists, biotechnologists, did an analysis of the virus of the genome of this virus. And it's a bit technical, so forgive me if I get a tiny bit technical here, but I'll try and keep it simple. What they were looking for were scars, birthmarks, things that would be left behind if you had stitched this virus together Frankenstein-like. Okay. Now, a common technique developed by a guy called Ralph Barrick in North Carolina, but copied and used by the Wuhan Institute of Virology when they were making chimera viruses, was called so-called reverse genetics. Basically, you make a DNA copy of this RNA virus, you break it up into 7 or 8 pieces, and you stitch those 7 or 8 pieces back together. And there are complicated reasons why you do it that way rather than doing it all at once. But you do this in order to be able to change one of the pieces, to alter it, to insert a gene from another virus, something like that. But you're looking for a virus genome that breaks up neatly into 7 or 8 pieces. So what you're looking for is the signature sequences at the joins that would tell you that this virus had been broken up and stitched back together using particular enzymes that they would commonly want to use in such a situation and that they have used in the past. And you find these, but you find them in all viruses. What you would expect to find if it had been stitched together in this way is that they would be very neatly spaced. They would be regularly spaced in the genome of the virus. They wouldn't be randomly spaced. So if they were too close together, one of them would have been removed. If they were too far apart, something would have been inserted. And that's exactly what they found. The second thing they looked for was if they did have such scars, such sequences, they would all be slightly different so that the system didn't confuse them one for each other, but they would still be recognized by the same enzyme. And again, they found that. And the third thing they predicted was that if they found these scars which had this pattern, they would be so-called silent mutations relative to related viruses. Now, what that means is that the change between a related virus and this one would not change the way the gene was translated into proteins. So it would not affect the proteins that could be produced from those genes. Now, normally you'd expect some of the changes, if they were random, to make a change, not to be so-called silent. So let me give you a quick analogy here.
Sure.
Changing the word yes to the word yay, Y-E-A, changes one letter, and it doesn't change the sense of the word. Yes and yay mean the same thing. Changing the S to a T, to the word yet, would change the meaning. So that would be a non-silent mutation, whereas yay would be a silent mutation.
And what would be the purpose of making a silent mutation?
Well, so you don't want to alter the way the virus expresses its genes while you're doing this. You don't want to do that in a way that you're not planning to. So in this stitching together process, you're trying not to affect the virus too much. Okay, so you want the changes to be silent at the joins, not necessarily somewhere else, but at the joins, you'd want them to be silent. I'm sorry it's so technical, but it just happens to be. And again, they found that that was the case. So they made 3 predictions, and they were all borne out. And again, this doesn't prove that that's what happened, but it's exactly the pattern you'd expect to see if they had done it that way.
So I guess the reason you would want them to be silent mutations is so that the virus itself still spreads the way you would normally spread, but now it's just carrying other enzymes with it.
Yes, roughly speaking. Spread is perhaps not the right word because remember, this is for laboratory experiments. We don't think that there was any intention to release this virus. But what they're doing in these chimera experiments, what they've been doing for a number of years and publishing, there's nothing secret about this, is collecting wild viruses from bats, finding that they can't grow those viruses in the lab, so they can't test how dangerous they are, but they know their sequence. But by the time you get them back from the wild, they're not in sufficient condition that they can replicate in the lab. But they have managed to grow 3 of them, basically. One of them called WIV1 and 2 others whose names I needn't bother you with. And what you can do is you can swap the gene from this newly discovered, you're finding hundreds of new viruses. You want to know how dangerous they are, or whether they're capable of infecting people. So what you do is you take WIV1, which is a relatively harmless domesticated virus that you've got growing in your lab, and you can infect human cells with it, and so on. And you take its spike gene out, and you put the spike gene of the newly discovered virus in its place. And in order to do that, you'd have to go through this reverse genetic system of copying it into DNA, stitching it back together, Frankenstein-like, and so on, and leaving these little scars. You don't have to leave the scars. You can get rid of them later. But maybe they didn't get around to doing that in this case. That's one of the arguments. And remember, the results of these experiments were that sometimes by putting a new spike gene from a newly discovered virus into an existing virus, they increased the infectivity of that virus in human cells up to 10,000 times. So they made it way more infectious. And sometimes in mice, they made it way more lethal. So it was 3 times as likely to kill a mouse. So some of these experiments were undoubtedly risky, and you wouldn't really want to be doing them in the middle of a city at all. And you certainly wouldn't want to be doing them at biosafety level 2, which is where they were doing some of these. And I think if I'd known this before the pandemic, I'd have raised a red flag about these experiments anyway. They are, by any definition, so-called gain of function experiments of exactly the kind that we had a big argument about in the US in particular in the mid-2010s about whether they were wise experiments to be doing, because you're basically looking for a gas leak with a lighted match.
You know what I love about fantasy sports is that even though I'm not going to be a great basketball player or a baseball player or a football player or whatever, I feel like I get to participate and make decisions and use my knowledge of these different leagues to or these different sports to compete. So it's like I can pick my team or I can pick my favorite players and I could use my knowledge to make predictions and maybe even make money. So with the basketball season here, you can now pick combo projections across football and basketball from the Specials League on Prize Picks. This is a league created specifically for combo projections that include two or more players from different sports or leagues. Want to play alongside some of Prize Picks' favorite players like rapper Meek Mill and comedian Andrew Schultz, who's also been a guest on this podcast, and I've been a guest on his? You can now find community plays under the promos tab of the app to view entries for some of the biggest names in the Prize Picks community each week. Look, Prize Picks even offers a reboot policy so that your entries stay in play even if one of your players gets injured. For football and basketball games, if you have a player who exits the game in the first half and does not return in the second, that player is rebooted. Prize Picks is the only daily fantasy sports platform with an injury insurance policy. What? So I love playing it. I love anywhere where I can use analytical ability with my interests to demonstrate some skill and maybe make some money. And I like the game like aspect. I do wish they had chess as a category on prizepicks.com, but I'll settle for what they've got. Maybe I should make my own fantasy chess league. But in any case, I love Prize Picks. Go to prizepicks.com/James. Use code James for a first deposit match up to $100. That's the easiest $100 you're ever going to make. So that's prizepicks.com/James and use code James. Daily fantasy sports made easy. The future of learning is definitely online. Like it's such BS that you have to spend $200,000 or take $200,000 in loans and go to some fancy school when it's useless. It doesn't guarantee you a job. Most employers, including me, do not care about degrees or grades or anything like that. We want to care that you love what you're doing, that you know what you're doing, in some cases that you have experience or that you're willing to learn. But people in general love learning and are curious. Like the key to success is curiosity. And I think masterclass.com is the perfect model for online learning. I'm really happy they're sponsoring this episode. If you're going to give a gift, give the gift of learning. Masterclass makes a meaningful gift this season for you and anyone on your list because both of you can learn from the best to become your best, from leadership to effective communication to cooking. Let me tell you some of the classes I've taken. I've taken comedy from Steve Martin. I mean, can you believe I can take a class from Steve Martin on comedy or Judd Apatow, my favorite comedy director? I could take an actual class from him on writing. Wolfgang Puck on cooking. Dan Brown on writing, or Judy Bloom, who's been on this podcast, on writing. By the way, Wolfgang Puck also has been on this podcast. It's such a pleasure. I try to take classes all the time from masterclass.com. And whether you're watching Masterclass on TV or listening in audio mode in the app or on their site, the quality speaks for itself. It's like these Masterclass instructors are your own personal mentors that are going to help you reach the next level. How much would it cost to take one-on-one classes on comedy from Steve Martin or on chess from Gary Kasparov? You just wouldn't be able to do it. But it would cost hundreds of thousands of dollars. With a Masterclass annual membership, it's $10 a month. Memberships start at $120 a year for unlimited access to one-on-one classes with all 180 plus Masterclass instructors. So it's not just $120 for one instructor. You get all 180 plus Masterclass instructors. Boost your confidence and find practical takeaways you can apply to your life and at work. And if you own a business or are a team leader, use Masterclass to empower and create future-ready employees and leaders. That's the real education in today's world. So this holiday season, you can give one annual membership and get one free at masterclass.com/JAS.
JAS, of course, stands for the James Altucher Show. So right now you can get 2 memberships for the price of one at masterclass.com/JAS. Masterclass.com/JAS. Offer terms apply.
When they were doing these experiments, did they understand how potentially lethal this particular one could be? Or did they think they were still dealing with mild, innocuous viruses?
Well, they published a key paper in 2015 in collaboration with Ralph Barrick, who basically taught them these techniques. And he's at the University of North Carolina, Chapel Hill. And he'd mostly worked on other kinds of coronaviruses. And in that paper, both Xi Zhengli of Wuhan and Ralph Barrick of UNC say very clearly, these are risky experiments. We need to think very carefully about whether we should continue doing them. So, they're not unaware that we are running a risk here, that we are playing a little bit of Russian roulette, and, that care has got to be taken. So, it's simply, if you talk to people who haven't followed this story, they think, oh, come on, lots of labs do lots of things. No, these virology experiments being done particularly in Wuhan, but also in North Carolina, but not so much with bat coronaviruses in North Carolina, were pretty exceptional and pretty worryingly dangerous. And nowhere else in the world was doing it like this.
And so, this leads to so many different questions. First off, the basic one, which is, could these scars that we've seen, or these observations that we've now seen in these coronaviruses, could they have a natural explanation?
Yes, they could. Viruses combine and recombine. So they naturally have natural joins that cause them to break up their genomes and adopt genes from other closely related viruses. That's called recombination. It happens naturally. It's unlikely that it would lead to quite such a regular pattern. It's unlikely it would leave only silent mutations. And it's unlikely that these mutations would all be just slightly different, but still recognizable by the enzyme. So, it's not, as I say, a 100% proof of anything. And I should add that my co-author, who knows more about this subject, finds that study less convincing than I do, because she says, look, there are ways in which these things can come about naturally. You are slightly straining to see a pattern here. When you look at a cloud and see the shape of a man's head, that's sort of slightly the kind of thing. If you want to see a man's head, you can see a man's head, but if you're not predisposed, then you don't. So I think there's a risk that we're doing that here, that we're over-interpreting some results. But I think this is it's not by any means the only bit of data we've got to say that something's going on here. Let's remember, the biggest bit of data we've got that the lab needs to be looked at is the fact that they have been unbelievably unhelpful and non-transparent in revealing what they were doing in the lab. Most of what we know, apart from the stuff they published, has had to be dug out from leaked documents, secret websites, and so on. Particularly, where they found the closest relative, what was going on there, how many viruses they got out of that site, when they sequenced them. All of these things they basically told fibs about at the start. And the biggest fib of all, well, it's not a fib, but the biggest problem of all, is that they have a database with all their viruses in it. As far as we know, it's got 22,000 entries. It's a huge catalog of all the viruses and bacteria they've looked at over the years. They took it offline between 2 and 3 a.m. on the 12th of September, 2019, and they've never brought it back online. And if the lab was completely innocent, that database would have no virus in it that at all resembles SARS-CoV-2. So publishing that database would be the quickest, surest way of exonerating the lab. it would blow me out the water.
Well,
So why don't they do it?
have they said why they don't do it?
Yeah, they've said people might hack it. What does that mean?
But it was publicly available anyway.
If you publish it, then it doesn't need to be hacked.
Well, so again, this leads to other questions. So Alina Chan, your co-author on Viral, she was kind of taking maybe a slightly opposing view. But if were these three scars or things that look like man-made attempts to change the virus, are they mutually exclusive of each other? In which case, the probability of each happening naturally, you just multiply them together to figure out what the probability of all of them happening is.
Yeah, that's roughly what Alex Washburn, who's one of the lead authors on this paper, has been arguing, that you should be able to multiply these probabilities together to get a pretty small probability that this is natural. And it's certainly true that his approach is scientifically correct in that he says, we then made a prediction that they would be silent. So they then went to look to see if they were. We then made a prediction that they would all be different, and they were. So it's not a case of sort of post hoc reasoning. They literally made their predictions, 3 of them, and then tested them, and they all passed. Now, I'm not a good enough Bayesian statistician to be able to tell you whether you can multiply those probabilities together to get a significant number, or whether you're flying by your seat of the pants here. But anyway, you get the point. You're probably better at this than I am.
Well, but an epidemiologist would know if these events were mutually exclusive, and then if someone just says, "Yeah, these don't happen together,"
not an epidemiologist, because most epidemiologists don't particularly know anything about genomes. I mean, I went on I watched a video call between Alex Washburn and a technical expert within a genome sequencing lab, somebody who really knows what's called bioinformatics, which is an incredibly sophisticated science these days. And it's the science of working out what a gene sequence is and how it's related to another gene sequence. It's almost like medieval textual analysis, this stuff, because it is dealing with a linear digital code, like a book, as it were. A virus genome is 30,000 letters long. A coronavirus genome is 30,000 letters long. It's a string of information laid out in a 4-letter alphabet. It's very like reading a medieval manuscript, trying to work out, did this monk copy that monk, or was it the other way around? That's the kind of analogy for what's going on here. And anyway, this expert had come to the question cold and confirmed that Alex Washburn and his colleagues were doing it right, that that he found it very persuasive. I wish I could remember his name at this point, but I can look it up.
And the other evidence gets back to what we talked about in the beginning. Just the coincidence that, like you said, these viruses come from all over China, but it just happens to be at the wet market near the biggest laboratory for studying these coronaviruses, where this was a super spreader event. That, to me, seems like a big enough coincidence. It's a reasonable question to ask. And yet in March 2020, so many people were against even talking or suggesting that this might have been a lab leak. Is that because the prevailing government message was, look, we don't want to make this an international event. We just want to focus on the virus? Or what was the reasoning behind not exploring the truth here? Whatever the truth is, they did not want to explore it.
Exactly. Well, we know some of the answer to that question, because there was a very important meeting the first weekend of February 2020, when this was still a cloud on the horizon. It was not, nobody thought there was going to be a global pandemic yet. They just thought it was a bit risky and a bit worrying. But the genome of the virus had just been sequenced. And Anthony Fauci, Jeremy Farrar of the Wellcome Trust in the UK, and Francis Collins of the National Institutes of Health got on a phone call together with about a dozen virologists, and they discussed this virus. Now, the reason for the call was because Jeremy Farrar had heard from three of them that their first look at the genome had made them very worried that it looked like it was engineered. One of them said, look, 80% likely. Another said 60, 40, that kind of thing. So he gets on the call saying, look, these three guys say, and they're on the call, that it looks engineered. Now, two other scientists who are on the call shoot this down and say, no, it's not, you're not right. But Farrar comes off the call saying, I'm still 50-50 about this. It might be. We knew none of this at the time. We didn't even know the phone call had taken place, by the way. But we found out some months later, really when Jeremy Farrar published a book, and then when Freedom of Information got hold of some emails. And what those emails showed is that within 48 hours of the meeting, they were drafting a paper to argue that it definitely didn't come out of the lab, and to say that that was a conspiracy theory that could be ruled out. Why had they changed their minds so fast? How could they be so certain? What had happened in that 48 hours? Some of the emails do shed light on that, because what they show is the scientists saying things like, the damage this could do to the reputation of science in general and Chinese science in particular, that's in quotes, would be significant. And another one says, we must shut this down for the sake of international harmony. So there was, and I think it's very clear, there was considerable pressure coming from China on Western scientists and politicians to reject what they said were extremely unfair and racist claims that this was somehow the result of an accident in a laboratory. And I believed it at the time. I actually called up a few virologists, including ones who were on this call I'm telling you about, and said, can you explain to me why you think it wasn't out of a lab? And they gave me reasons which I didn't find very convincing, but I thought, well, they must know what they're talking about. I wrote an article for the Wall Street Journal saying, well, it didn't come out of the lab, but here's what we know about the bats and things like that. Well, I feel a fool now. Some of these guys I was talking to were thinking secretly that actually it might have done. There was one piece of evidence came out in that early February period that bolstered their confidence that they could rule out a lab. And it later completely evaporated as a piece of evidence. It was the argument, if you remember, that a pangolin had been found infected with a similar virus. Now, a southern Chinese university announced on, I think, it might have been the 7th of February, that they'd found a pangolin with a 99% similar virus. Now, that would be big news, because this is exactly what was found in the case of SARS in 2003, a civet cat with a 99% similar virus. This is the smoking gun we're all looking for. Great. Well, it took 3 weeks before the study that the press conference at this university had mentioned came out. And it wasn't 99%, it was 90%. Well, that's a way massive difference. I mean, that's more distantly related than we are to chimpanzees. I think it's more distantly related than we are to monkeys. So
what about what's the distance between the common cold and COVID?
Oh, well, that'll be a lot greater distance, but because the common cold is not a coronavirus. I mean, just to give you, the genealogy here, there are viruses. Some of them are coronaviruses. Some of them are beta coronaviruses. Some beta coronaviruses are SARS-like or sarbecoviruses. SARS and COVID are two of those. So was this so-called pangolin virus. But it then emerged that the pangolin data was all over the place. It was confused, contradictory, repetitious, inaccurate. It came from just two animals. They were not found in Wuhan. They were found in Guangzhou, 1,000 miles to the south. No wild pangolins had this virus. In fact, it looked more and more like it was simply a case of contamination of a sequencing machine. That the same sequencing machine that had been looking for viruses in these confiscated pangolins in 2019 had been used for some kind of experiment on a SARS-CoV-2-like virus. But anyway, the point is the pangolins did not rule out the lab leak at all. They turned out to be a complete red herring, if you like. Bat viruses were 3 times as close to SARS-CoV-2 as the pangolin viruses. That's the point. And the pangolin didn't have this crucial insert called the furin cleavage site, which is the thing that means we're having a pandemic.
And it's funny because I still thought until just now that it was a pangolin that they first discovered this in. And I thought maybe the lab had leaked to the pangolin and then to the wet market. So all of the news in the first few weeks, and this is going back to March 2020, February 2020, all of the news said pangolin. I've never heard any of this other news that they've debunked that since then. So
yeah, but it's well known within science. I mean, some of the debunking was done by Alina Chan. She analyzed the pangolin papers and said, hang on, this paper talks about 4 samples, but they're exactly the same as the other paper. You've just given them a different name. Stuff like that. They eventually had to print a massive correction to those papers because they'd been rushed into print without proper peer review, and they were full of holes, contradictions. They were a mess, basically. We don't really know what they found in a pangolin. Some traces of a coronavirus was in there. As I say, it might even have been contamination of the machine they used for the sequencing. That does happen from time to time.
So, on the one hand, it seems like the simplest explanation is there was a leak and they didn't want to distract focus on just curing this virus, and they didn't want people to worry about international relations and science itself and so on. So as people do, they cover things up. But, is there any room for a more insidious explanation? And I don't know what that might be. Maybe there's financial motivation. Maybe, I don't know. Is there other speculation about why people just weren't allowed to talk? Like, again, I had podcasts in March 2020 with, high up virologists and epidemiologists, and nobody said anything other than this is definitely not a lab leak.
Yeah.
So was there any other incentive?
Well, yes. I mean, there was clearly among Western virologists, there was a political preference for Donald Trump not to be proved right about something. We can all sort of sympathize with that. So there was a political angle there. But also, the issue of military involvement can't be completely ruled out. And, well, now let me put it a different way. We know that there was collaboration. There's a lab further east in China, in Zhejiang, which had found 2 coronaviruses that are not dissimilar to COVID a few years before. They're not nearly close enough to be the progenitors, but they are cousins, as it were. And that lab is basically a military lab. And there is an odd feature of the publication about these kinds of viruses before the pandemic. They went to this mine shaft in southern Yunnan where 3 people had died and 3 others had got very sick after shoveling bat guano. They went there 7 times over 2 years, in 2013 to 2015. They brought back a bunch of viruses, one of which turned out later to be the closest relative of SARS-CoV-2. They also brought back 8 other closely related viruses. They've never really published those. They sort of say, we published some of it, or they then did produce a sequence, and they kept changing their minds about exactly how they described them. They even changed their minds about which species of bat they'd found them in. But there was a thesis that was published in 2018 by a person named Yu Ping, and it analyzed these other 8 viruses. It was never published. Sorry, I said it was published. It was written, but it was never published. But a wonderful sleuth called the Seeker found it. And it very clearly showed these 8 viruses and how they were related to a bunch of other viruses in a sort of fan-like family tree. Now, she then published a paper based on her thesis in the scientific literature, which had exactly the same image in it, the same chart, except that these 8 viruses had been cut out. Right. Why would you do that? This is before the pandemic, remember. This is a year before the pandemic. It's almost as if someone had taken a decision within the Chinese government that a line of work would be done, either a nefarious one involving the People's Liberation Army, or more likely just a scientifically ambitious line had been taken, saying, right, let's keep this group private because we're going to do a bunch of really interesting experiments on them, which will get us a Nature paper that we can then translate into very high status within science and maybe even get the Nobel Prize or something. That's the sort of theory that one should consider. But I've gone way too far in speculating. I try never to speculate about why people did things. I'm more interested in what they did. That's just one possibility. But it does continue to intrigue me why Yu Ping would have one chart in her thesis and exactly the same chart, but with a bit of it cut out in her published paper. And that bit happens to relate to 8 closely related viruses to SARS-CoV-2.
Oh my gosh, I love these clothes. Mizzen and Main, that's Mizzen and Main. It really is the most comfortable work clothes. Travel clothes. I had to travel this whole week. I'm traveling for a week and a half, and I just took Mizzen and Main clothes with me. Close out 2023 in style with comfortable, breathable, packable, and machine washable pieces from Mizzen and Main. As you wrap up your year-end goals, enjoy a Mizzen and Main dress shirt that you can wear confidently. I like that they've very, very just nice, solid colors. I don't really like to get all fancy in patterns and everything, although they do have some pattern shirts, but very comfortable clothes, stretchable pants. It's just super comfortable, but they look professional and you can wear them casually or professionally. I like some of their flannel shirts or untuck shirts. I love untuck. I never tuck in. So again, whether you're shopping for a special someone or giving yourself the gift you really want, I just buy myself gifts. Mizzen and Main is the perfect gift for any guy who works, travels, and or cares about looking and feeling great. As you could tell by my many photos across the internet, I care about looking fantastic. I'm practically a model. And let's be honest, every guy loves to look great. So again, shop now at mizzenandmain.com and save 20% when you spend $130 or more using promo code James. That's promo code James at Mizzen and Main, Mizzen and Main.com.
This is such a valuable service for all business owners, big businesses, small businesses, doesn't matter. I wish I had this in the many different businesses that I've started. Sometimes it seems like your business is humming, but then suddenly you don't understand it. You're starting to fall behind. You're not understanding where your costs are, where your revenues are, where your payments are. Teams are buried in all sorts of like BS work, and you can't seem to close the books. So you need like one dashboard, one source of truth. I'm jealous of this business, NetSuite from Oracle, of course, NetSuite by Oracle. I wish I'd come up with this idea. It's a brilliant concept to have all your business intelligence on one dashboard. This is why you need to know these 3 numbers: 37,000, 25, and 1. So 37,000, that's the number of businesses which have upgraded to NetSuite by Oracle. NetSuite is the #1 cloud financial system, streamlining accounting, financial management, inventory, HR, and more. 25. NetSuite turns 25 this year. That's 25 years of helping businesses do more with less, close their books in days, not weeks, and drive down costs. 1, because your business is one of a kind. So you get a customized solution for all of your key performance indicators, your KPIs, in one efficient system with one source of truth. Manage risk,
Get reliable forecasts and improve margins. Everything you need to grow all in one place. So right now, download NetSuite's popular KPI checklist designed to give you consistently excellent performance absolutely free at netsuite.com/James. That's netsuite.com/James to get your own KPI checklist. netsuite.com/James.
I guess the other thing is, if we do think this is a virus created in a lab, there's sort of an ongoing existential fear that arises from that conclusion, which is that if they can make this virus and accidentally leak it, they could certainly make another virus 10,000 times more lethal than this one and weaponize that. And when I say they, I'm not referring to I'm referring to anybody, because the technology,
Exactly.
anything that's hard now, we know thanks to in part work done by you, we know that 20 years from now, anything that's hard now is going to be easier later. So how easy is it going to be in 2040 for someone with a homemade genomics kit to make a virus and just spread it around their school, and that's the end of humanity?
Well, forget 2040. You could do it in 2023. The techniques for doing this stuff, they're not trivial. You can't do it in a school lab, but they are relatively routine now. And you're right that there are three reasons why I think we must find out what happened. First of all, so we know how to prevent the next pandemic, because if the wildlife food chain is responsible, then we need to crack down on the wildlife food chain. If virology research was responsible, then we need to regulate virology research. We're doing neither. We're plowing on as if nothing had happened in both those areas. The second reason is because 20 million people are dead and we owe it to them to find out why. But the third reason, and the one you've touched on, is that bad actors are watching this episode with relish. The North Korean regime, Al-Qaeda, I can't prove that, but I think it's highly likely that anyone with a wish to disrupt the world is thinking, whoa, all I need is a infectious virus that's not particularly lethal. In some ways, it's better if it doesn't kill everybody because it spreads so much faster. Ebola is not such a threat as this thing was to the world economy. So all I need to do is go and harvest some of these things out of bats and test them in a lab and maybe manipulate them a bit, but maybe I don't even need to do that. And then, best of all, once I've done it, the World Health Organization will come steaming into town and say, oh, don't worry, it probably came in a frozen lobster from Maine, which is roughly what they said a year and a half ago, to my absolute fury at the time. So, and yes, it is the bioterrorism threat that we need to take extremely seriously after this pandemic. And I'm not the only one saying that. There's a guy called Hamish de Bretton Gordon in the UK here who used to be the commanding officer of the Biological and Chemical Defence Regiment in the British Army. And he's going around very strongly saying, this is the real worry, that intelligence suggests that bad actors have pricked up their ears.
And, also another perspective from the point of view of the economy. I mean, you're an economist. You've written many times about the economy. Do you think the response to this, which is essentially shutting down all of the economy, forget about the effect this had on the economy, which was obviously negative. Do you think the response to this, if you were to guess, did this save a large percentage of lives, or was useless, or somewhere in between?
Somewhere in between. I hesitate to say we could have got away with no lockdowns at all. I suspect that's going too far, although the case of Sweden suggests that voluntary measures could have done an awful lot with some banning of big groupings and things like that. I think it's likely that we certainly went too far with later lockdowns. In Britain, we were about to lock down in December 2021 when Omicron was spreading. at the behest of scientists who were urging the government to do so and saying 6,000 people a day might die if you don't. And the government resisted that and were right to. So we do need to have a long, hard look at the kind of advice scientists are giving in situations like this. It's a bit of a scandal as to how alarmist a lot of them were. But I have a particular worry, which is almost unique to me. Nobody else seems to be making this argument, but it's based on a very sound theory about epidemiology from a guy called Professor Paul Ewald, who has pointed out that on the whole, respiratory viruses spread through the air do tend to evolve into mild forms. And you can see immediately why, because if you're feeling sick and you decide you're too ill to go to a party, then you don't spread it. If you go and cough over people at a party, you do spread it. That's not true of other kinds of viruses. So this isn't a general theory that all viruses will become mild, because insect-borne diseases almost want the opposite. They want you lying in a darkened room, delirious and not noticing the mosquitoes. So it heavily depends on the mode of transmission of the virus, whether it evolves to be mild or not. And his point is that it's no accident that there are 200 different kinds of virus that cause the common cold. Some of them are coronaviruses, some of them are adenoviruses, some of them are rhinoviruses. None of them are lethal. They might kill a very, very elderly, a very sick person, but they are basically extremely mild viruses as viruses go. So I think this thing would have evolved into a mild form pretty quickly. But we intervened, and certainly in the UK, and I think in the US, we did something really counterproductive. We told you right at the start, if your symptoms are mild, stay at home. If you've got severe pneumonia-like symptoms, come to the hospital. And where did it spread fastest in the early months? In hospitals. So I think we were telling the virus, please be as virulent as you want. And it wasn't until we started opening up that the mild strains like Omicron could then get to work and expel their rival, more virulent strains. And by the way, this pandemic has shown us very clearly how one strain displaces another. Delta drove out Alpha in the flash of an eye, and Omicron drove out Delta extremely quickly too. So the biggest enemy of one strain of virus is another strain of virus, if you like. And so I think we prevented the evolution of the virus into a milder form with our lockdowns in the early days and our policy of telling people to stay at home if they had a mild version.
And so now, from your perspective as the author of The Rational Optimist, now that we're aware of this, could it be that the pace of technology for curing these sorts of viruses outpaces the potential for destruction of these viruses?
Well, here's where I made a mistake. I did say in The Rational Optimist, lots of things are going to go wrong in the 21st century, including pandemics, I said. So, I did at least say that. But I then made a mistake. I said, genomic knowledge is advancing so rapidly that I think the pandemic threat is going to get easier to deal with. And I based that on a chance conversation with the chairman of the Wellcome Trust soon after the SARS outbreak, when he said, it's incredible. Our scientists have sequenced the entire genome of that virus in 3 weeks. Nothing has ever happened that fast before. This is back in 2003. Now, of course, you can do it 24 hours now, even faster. And I remember thinking, that's just an example of how our tools are going to enable us to keep one step ahead of the enemy here. Well, it turns out that in 2019 to 2022, we could sequence the virus in 24 hours, and we could sequence millions of people. We could do mass sequencing. We could test till we were blue in the face, test and trace, and it couldn't stop the virus spreading. Test and trace was pretty useless in most countries. There's the Cassandra syndrome. Cassandra told the Trojans that she could see the future and it wasn't good. Would they please listen to her? And they didn't listen to her. We're in a position where we can sort of see what's happening but do nothing about it. And I worry that we've developed the technology so we know what's going on, but not so we can stop things happening. Will that change? Yes, it will. And my optimism is extremely buoyed by what happened with the messenger RNA vaccines. They're not perfect. They weren't as good as we'd hoped, but they did prevent an enormous number of deaths. And they were produced within a year. And we've never done that before. And that's because that technology for producing vaccines, it may not produce the best vaccines because it only, does it from one protein rather than the whole virus and things like that. But it's really fast. And I think with that in our toolkit, imagine if it happened now, we could probably ramp up a messenger RNA vaccine and get it to Wuhan, the hospitals in Wuhan, in December or very early January of 2020, and nip the thing in the bud, rather than wait till it's all over the world when it was too late to stop it spreading.
Do you think genomics will ever get to the point where highly personalized, a highly personalized approach using something like the next generation of CRISPR could go into a person and, genetically modify the virus right inside of you and eliminate it?
Well, I think for cancer, yes. I think that's the great wide hope. And that, by the way, is what the messenger RNA technology companies were looking at before the pandemic came along, is curing cancer. There is already immunotherapy techniques where you basically work out exactly what cancer you've got, not roughly what kind, but exactly what its antigens look like, down to the very last detail of the sequence. And you design an antibody that is precisely right for your cancer, nobody else's. And you inject it back into your cell with so-called CAR T cells. That is already happening in some cancers, particularly in some blood cancers. And it's saving lives already. So personalized medicine is coming, is going to make a difference, and is a huge hope. And so I think, can you apply that to infectious diseases? Possibly, although, certainly you'd want to customize a vaccine for Omicron rather than Delta or whatever it might be. Certainly we're going to be doing that kind of thing. And could we apply it to other things? Could we, prevent the diseases of aging this way? Yeah, why not by 2050?
And now on the perspective of the economy, obviously COVID was a virus that was on humans, but it also became a virus on the economy. The whole world economy bowed down to it, shut down. We're paying the bill now for all the trillions that were spent or were lost during that period. And I'm speaking now totally from an economic point of view, and talking to you as an economist. What's your perspective on what's next for the economy? How do we come out of this sort of weird period where it really is true that this is unlike before what we're seeing now?
Yeah, and there's things about this that really worry me. I mean, the UK has published figures today showing that its government as a percentage of the economy, which was intended to be, which was, I think, 38% before the pandemic, which was pretty high, actually, historically, is going to be 47% next year. Now, that isn't a great future for a country like the UK, where half the activity that people are doing is for and through and by the government, because the government needs taxes, and it has to get taxes off people who are not in the government as well as people who are in the government. Otherwise, you're trying to run a perpetual motion machine. So I really do think that we have stumbled into a very high public spending, very top-down and centralized view of the economy that isn't a great one. And at the same time, you've got, the US economy stumbling a bit and becoming much more sort of social democratic, a la European, not turning into a top-down socialist state or anything, but it's heading a little bit that way. And you've got China, which has been an engine of spectacular economic growth in the world for 30 or 40 years now, but was very economically free while being very politically unfree. You really could set up a business with very little regulation in China, of the sort of petty kind, as long as you didn't annoy the Communist Party. That's changed. Xi Jinping is a deep, deep centralizer on the model of the Ming emperors or Mao Zedong. And so I worry as to who is going to drive the engine of innovation, which is the source of true growth in the world, in the coming decades. I don't see it being Europe. I see it being America to a large extent, but not entirely. Countries like Japan had a crack at being that engine, and they're not so good at it these days. China is turning its back on it. India is a good hope. I think India is a dynamic place and is going to source a lot of innovation for the world eventually. Parts of Latin America too. But, the kind of things America did in the 90s, developing e-commerce for a start, they weren't random. They weren't bound to happen. They happened because smart people had the freedom to make them happen. And I worry that we're not in a position to see that happen anywhere in the world. But I keep telling myself not to worry, because to remind myself I'm a rational optimist. That, when I wrote The Rational Optimist 12 years ago, everyone was incredibly pessimistic about the future. They always are, they always have been, and they've always been wrong. So I'm probably wrong to be pessimistic now.
I mean, in 2008, I remember overhearing I was in a restaurant near Wall Street, and there were some bankers at the table right next to me, and they were talking how basically they were saying Goldman Sachs is bankrupt, Morgan Stanley's bankrupt, it's all going to happen in the next few days, capitalism is over. And of course, these very smart, intelligent people were 100% wrong. And like you say, every 10 years, some report comes out, says the world's not going to survive another 10 years. And that's always been wrong.
Exactly.
Since forever.
Since forever. I mean, I found this wonderful quote from Thomas Babington Macaulay in 1830 at the start of the Industrial Revolution in the UK, lambasting Robert Southey, who'd written a book saying this Industrial Revolution lark is a terrible idea. It's going to end in disaster. And he was saying, why is it with nothing but improvement behind us, we're to expect nothing but deterioration in the future? And so I do remind myself of that as often as I can. I think as long as we let them, entrepreneurs are going to find ways to improve all our lives over the coming decades. And 2030 is going to be great. 2040 is going to be great. Not for everybody and not everywhere and not without its problems. But I remain an optimist. But I've always said the two things that bother me, are not climate change and whatever else it might, and artificial intelligence or whatever else people might say. They are bureaucracy and superstition. If we turn our back on the Enlightenment, then all bets are off. And if we decide to just simply clog up the arteries of the economy with far too much delay and indecision from bureaucrats, then we might achieve the same results. Those are what have stopped empires going on and being prosperous in the past, whether it's the Roman Empire or the Arabian Empire or whatever. It's some combination of bureaucracy and superstition.
Well, Matt Ridley, author of Viral and, of course, The Rational Optimist, The Evolution of Everything, and so many other great books. I really appreciate you coming on the podcast. It's always so fascinating to talk to you and get your insights. I learn from them, and I hope the listeners do as well. And I really appreciate it.
Thank you, James. It's really enjoyable talking to you. I'm sorry I've just blathered on so much.
No.
Talk me on a loquacious day.
Much more important for you to blather on than for me to blather on. So thanks again.
Oh, it's great to talk to you.
Hi, I'm Jim Purdue of Purdue Chicken. Unlike our competitor, who's gone back to feeding their chickens antibiotics, we at Purdue will remain no antibiotics ever. No antibiotics ever because we raise our chickens in a healthy environment, so they don't need them. No antibiotics ever takes more time and money, but it's the right thing to do. So when you buy chicken, look for the Purdue label to make sure your chicken is no antibiotics ever. Get the facts at Purdue.com.
It's time to save. Clear the Rack is on at your Nordstrom Rack store. For a limited time, take an extra 25% off clearance. All sales are final. Hurry, shop this sale at Nordstrom Rack today. Please see nordstromrack.com or ask a store associate for details.